For the following arithmetic progressions, write the first term A and the common difference D. So the first term is always, in all the cases, is the first element. All these are first term. And how to find the common difference? If I take this one, minus 5, minus 1, 3 and 7, you just have to take the second one, that is minus 1, and subtract the first one. So minus 1 minus is plus 6. 6 minus 1 is 5. So 5 is the common difference. You can check it for any of the consecutive values, like 3 minus 3 and minus 1. So minus 1 and 3, what we have to do, take the second one and subtract the first one from it. That is 3 minus 1 is 4. So here we have this is minus 5 plus 5. 5 minus 1 is 4. So I just verified it and I found that it is 4 and 4. Let us check it for 7 and 3. 7 minus 3 is what? It is 4. So everywhere you have to find like this. So this is the common difference. It has to come for every consecutive value. The difference has to come same. Then only this list or this sequence will be, or this progression will be in arithmetic progression. Let us take one of these, this fourth one. So this is the solution of the first one for your reference, because the first one is A, the second one is A plus D, third one is A plus 2D, next A plus 3D. Likewise, it goes up to A plus n minus 1. Let me write it here. A plus n minus 1 into D. So this is the nth term. So you can find out any of the term like this, and this is how it goes. So the first one is always the first term, which is A, and if you subtract this, say A plus D minus A, so A plus D minus A cancels, so D will come. You can take it for this one also. A plus 2D minus A plus D. So what do you get? A plus 2D minus A minus D. A cancels, 2D minus D is D. So every time it will come as D, 4, 4, 4 like this. So let us take this one now, fourth one. This one. What is the first term, which is minus 1.1? So this is the A. So the general series will be A plus D, A plus 2D, A plus 3D like this. First term is this one, minus 1.1. So this is the first term. How to find out the common difference? Just take this value, the second value, minus 3.1, and subtract the first value from it. So minus 1.1. So this will be minus 3.1 plus 1.1, and this is going to be, what this will be? Minus 2. You can take any of this. Minus 7.1. Minus 7.1 minus of minus 5.1. This is going to be minus 7.1 plus 5.1, and this is going to again be minus 2. So minus 2 is the common difference. Write the arithmetic progression. The first term A and the common difference D are as follows. Now here the question is the reverse of the first question. That is, here A and D is given. You have to find the arithmetic progression. So it's quite easy. See, A and D is given. First term is what? A, so it is 4. Then the other term will be A plus D. 4 minus 3. That is, 4 minus 3 is what? Let me write 4 minus 3. Then A plus 2D means 4 plus 2 into minus 3. Then A plus 2D, A plus 3D now. Next one, 4 plus 3 into minus 3. Minus 3, yes. So what will be this? 4 minus 1 is 1. Then 4 plus 2 minus 3, 4 minus 6. This will be minus 2. Then 4 plus 3 minus 3. So this will be minus 9. 4 minus 9 is what? Minus 5. So this will be 4, 1, minus 2, minus 5, minus 8 like this. Let us take the last one. Here A is minus 1.5. So first is A. Then we have to find out the series. So it will be A plus D. A is minus 1.5. A plus D is minus 1.5 plus D is minus 0.5. A plus 2D is what? Minus 1.5 plus 2 into minus 0.5. Likewise, A plus 2D, A plus 3D, A plus 5D, any number of elements you can write of this series. This is minus 1.5. What will this be? Minus 1.5 minus 0.5. So what this will be? This is minus 1.5 and this will be minus 2. This is minus 1.5 into 2 into 0.5. So this will be 2 into 0.5. So it will be 5, which is 1. So it will be minus 1. So minus 1.5 minus 1 is minus 2.5. Likewise, you will get the other values also. You just have to do A plus 3D, that is minus 1.5 into 3 into 0.5, and this will be minus 1.5 minus 3 into 0, 3 into 0.5 is 1.5. So minus 1.5 minus 1.5 is minus 3. In which of the following situations the sequence of numbers formed will form an AP? The cost of digging a well for the first meter is 150 and rises by its 20 for each succeeding meter. So you have A, the initial one, 150, and the D is also given. That is, it rises by 20 at each succeeding meter. So D is 20. So first is 150, then we have 150 plus 20 as 170, then 170 plus 20 is 190. So it is a proper AP. So this is the condition. See, we have 150 as the A plus D is 170. Then again, this one is A plus D, A plus 2D is 170 plus 20, 210. So this is actually a sequencer number which is showing that it is an AP, arithmetic progression. Now let us come to the amount of air present in the cylinder when vacuum pump removes each time 1/4 of their remaining in the cylinder. So here, first of all, the amount of air present in the cylinder when a vacuum pump removes each time means if you assume that V is the initial amount. So next time it removes V minus V/4. We have to subtract this. The initial was V, then 1/4 of V is removed. So what do you get? V1 minus 1/4, that is V3/4. Now this V3/4, so we have V3/4. Now 1/4 of this one means 1/4 of whole of this. V3/4 is removed. So let us take this V3/4 common. What do you get? 1 minus again 1 minus 1/4. So you get V3/4 into 3/4. So this will be V3/4 whole square. So the first term is V3/4V, this one. Second term is 3/4V square V, and if you do for the next time, that is again take 1/4 of this and subtract it. You will get 3/4 whole cube V. So this is not an AP, because if you subtract this and if you subtract this, you are not going to get the same value. But this is in GP. If you divide this by this and this by this, you are going to get 3/4 as the you can say common ratio. This is not in AP, but it is in GP, geometric progression. Show that the sequence defined by AN equal to 5n minus 7 is an AP. Find its common difference. So we have AN as 5n minus 7. 5n minus 7. So let us take the how do we find out the common difference? We take this one and let us take AN plus 1th term, next term, it is 5, this is 5n. So 5n plus 1 minus 7, that is going to be 5n plus 5 minus 7, this is going to be 5n minus 2. Now what we do in common difference, we take this one and subtract this out of it. So 5n minus 2 minus of 5n minus 7. So what do you get? 5n minus 2 minus 5n plus 7. This goes, 7 minus 2 is 5. So D is 5. Common difference is 5. Show that the sequence defined by AN equal to 3n square minus 5 is not an AP. How do we find out that it is not an AP? So what we will do, same thing we are going to do. See, AN is 3n square minus 5. How about AN plus 1? 3n plus 1 whole square minus 5. I am just putting n as n plus 1. So this is going to be 3. N plus 1 whole square is n square plus 1 plus 2n minus 5. This is going to be 3n square plus 3 plus 6n minus 5. This is going to be 3n square plus 6n minus 2. Now what we have to do in order to find out the common difference, AN plus 1 minus AN. So this minus this. So 3n square plus 6n minus 2 minus 3n square minus 5. So 3n square plus 6n minus 2 minus 3n square plus 5. Now this gets cancelled. You get 6n, and here 5 minus 2 is 3. So 6n plus 3 is the D. But if you see, in all the AP we have seen D is always constant. The common difference is always constant. But here, this is dependent on n, and n is a variable. N is a variable. So when n is a variable and you find out that d is not a constant value, then you can easily say that this is not an AP.